how we understand energy, matter, and the components of the observable universe. It also involves quite a lot of maths, which some people can find off-putting, but due to a phenomenon called maths anxiety, you're probably not nearly as bad at doing calculations as you might think you are, and I'll prove it. Because today we're going to look at Hooke's law, and we're going to do a variety of calculations ranging from easy to medium to hard. We'll work through them together, and I promise that by the end of this, you will feel more confident in your mathematical ability. Let's take this to the lab. Welcome to the lab, where we can discuss Hooke's law. This is the idea that the extension of a spring is directly proportional to the force applied to it. So here this spring is being extended because I'm applying force. This is represented by the equation force equals spring constant times extension, or F equals K times E. We can represent this mathematically. Let's do an example equation together. Let's say I have a spring that moves from 5 to 10 centimeters. First, we need to work out the difference in the length that that spring stretches. So in this instance, 10 minus 5 gives us a total stretch of 5 centimeters. Then we're going to convert that 5 centimeters into meters by dividing by 100, because as you'll recall, this equation is measured with meters, not centimeters. So we get 0.05 meters. Next, we have to plug in our value. So we've been given in our equation that the spring constant is 100 newtons per meter. Let's calculate the force together. 100 newtons per meter times 0.05 meters gives us a total force of 5 newtons. Let's try something a little bit more challenging and calculate spring constant. You'll need to rearrange the equation in order to do this. I'll give you a couple of minutes to try on your own, and then we'll go through the answers together. Pause the video now and take as much time as you need to complete the calculation. As you can see here, step 1 is to find out the difference in length that the spring stretches. So 5 centimeters minus 2 centimeters gives us 3 centimeters. Then again, remember we're measuring in meters, so we need to convert from centimeters to meters by dividing by 100. After that, we rearrange our equation, so we'll be dividing rather than multiplying. We plug in our numbers, and we get a spring constant of 66.7 newtons per meter. This final question is our most challenging. We're going to calculate the end length while knowing the spring constant and the force applied. Pause the video now and take as much time as you need to complete the calculation. In order to complete this calculation, first we must do step 1, and in order to do that, we need to find our extension. So 4 newtons divided by our spring constant of 80 newtons per meter gives us an extension of 0.05 meters. We then need to convert this back into centimeters by multiplying by 100. This gives us 5 centimeters. Finally, we add 5 centimeters to 7 centimeters, and our final extension is 12 centimeters. And much like a spring with increasing force being applied to it, it's important that you have a healthy balance of work, self-care, and other such activities, because otherwise you might be a spring that loses its ability to bounce back. So there you have it, science kiddos. We've completed 3 equations together, and you should understand a little bit more about Hooke's law, an aspect that is integral to many branches of science and engineering. It's also used in watchmaking, the study of acoustics, which is how we understand how sound travels, and seismology, which is one of the ways that we can predict and help keep people safe from earthquakes. If you want to understand more about maths anxiety and how to overcome it, we've linked some reading materials in the description for you. And if you've got a science topic you'd like us to explore in more detail, please leave a comment below or reach out to us on one of our social medias. Stay safe, drink some water, and remember, there's no room for shame when growing your brain.